Welcome to our lesson on applications of trig functions. So for our first example, we are given the graph in a scenario. So when the last person gets on a Ferris wheel begins to rotate, this graph shows the height above the ground of that person as a function of time. So as our y values, we have the height above the ground if we're on the Ferris wheel, and then on our x-axis we have the time. So our first question is, how high above the ground is a person when they first get on the Ferris wheel? The first thing I'm going to do is figure out what our middle line is, or midline. And it looks like it's going to be somewhere around here, just to make sure everything's even above and below our midline. And we're going to count and see what our amplitude is, to make sure again that we have the accurate midline. So this would be what, 25? So this would be 45. So the difference between 25 and 45 is 20. Okay, so the amplitude from here to here is 20. Now let's look below. Our minimum is at 5, so between 5 and 25 again is 20. So we found the correct midline for sure. Alright, so how high above the ground is a person when they first get on that Ferris wheel? That's going to be at our minimum, because when they first get on the Ferris wheel at 0 minutes, they're already 5 feet above the ground. What is the radius of the Ferris wheel? So that would be from the top of our Ferris wheel to our midline, or from the midline to the bottom of the Ferris wheel. That will help us determine the radius. And we found the amplitude of that was 20. And if you want to do an actual calculation, you could have done 25, which is at the center of the Ferris wheel, or midline, minus 5, which is the bottom of the Ferris wheel. And that's how we would have gotten the 20 feet radius. What is the time for one revolution of the wheel? Recall that one revolution is a full period. So let's take a look to see when that would happen. We're going to start at 0. So when is it going to hit 0 again? Over here. When's it going to hit the minimum again? So it hit the minimum again at 2 minutes. So your period is 2 minutes. So the period is 2 minutes. So example 2, we have a Singapore Flyer. It's the world's tallest Ferris wheel. People ride the wheel in capsules. The wheel has a diameter of 150 meters and it completes one revolution in 32 minutes. A capsule reaches a height of 165 meters. Determine a function that models it and then sketch it as well. So in this case, we're given the scenario and we have to graph it. We're going to analyze every little bit to help us determine how we're going to graph. So I'm going to go ahead and draw the x and y axes. For our x-axis, we're looking at time in minutes. And our full period is 32 minutes, so I can just maybe write that at the very end, 32. Then half the 32 is 16, which is approximately over here. Okay, and then looking at our height, our maximum height is 165 and we have a diameter of 150, so I should maybe go up by 50 here. Okay, so then we have our y-axis, which describes the height of the Ferris wheel. Then we have to also find where our max and min is. Well, we know our max is 165 already. Our min we can find pretty easily because we know the diameter. So that'll be our maximum minus our diameter, which gives us 15. So the very bottom of the Ferris wheel is going to be 15 then. So between 15 and 165, this will help us determine what our middle line is. So our midline is going to be 15 plus 165 divided by 2, which is 90. Gonna find the average between the two is what we did. So it's approximately around here. I'm just gonna draw it dotted. Okay, and then I guess we are ready to go ahead and draw this. So we are gonna start off at 0 minutes. And then our minimum is 15. So right when we get onto this Ferris wheel, it's gonna be 15 meters above the ground, so it's gonna be somewhere there. And then we also need to finish there after 32 minutes as well. Then our maximum is going to be right in the middle at a time of 16 minutes. So that's 165 as the height, so that's approximately here. And then I'll just follow through with connecting the points. And this is a one whole period. Now, we're going to analyze every little bit to figure out what our equation is for this. So the amplitude is determined from our middle line to the tallest point. So amplitude is then going to be the tallest point, which is 165, minus the midline, which is 90. And that's 75. So that's our amplitude. Our midline also tells us how high we are translating up, so we're going up by 90. And then now we have to figure out our frequency, which is 1 over the period. 2 pi over the period. And our period is 32. And then simplifying this would be pi over 16 as our frequency. Now I have to figure out if it's cos or sine. I'm just going to use cosine because cosine usually starts along our y-axis and it starts with our maximum. But we know how much we shifted over for our maximum, and we shifted over 16. Okay, so then for our shift, we can say 16 to the right. So now we can put it all together. Y equals amplitude 75. We use cos. Our frequency is pi over 16. We went 16 to the right and then up 90. So that is one possible equation we could have had. For this, try it yourself. You can do this one on your own. And when you want to see the solution, just go into the OneNote and look at the completed solution, because it's going to take up more time to do a question like that. But it's very similar to the one we just did. And then for example 2, this time we're given a table of values for us to draw. And then we're going to use this data, draw it, then create the equation for our trig function. So then I'm going to go ahead and draw in our x and y axes. Okay, and if you look at our time increments, we're going up by 2. So that's what we're going to go up by here. And there we go. And we can just stop there just because the time stops at 22 for our chart anyway. It's our time in hours. And then for our height, this is in meters. We're going to look for our highest height and our lowest height. So our lowest height is going to be 0.63, and our highest looks like it's going to be 7.8. So I just had to make sure that we go high enough for that. Let's go up by 1. Notice the typo here. This is supposed to be 6.3. The decimal place got moved. So now I'm going to go ahead and put in our points. So we have 0, 6.3, 2, 7.8, 4, 6.1, 6, 3.2, 0, 1.4, 10, 2.7, 12, 5.6, 14, 7.5, 16, 6.3, 18, 3.7, 20, 1.7, and lastly 22, 2.6. So I'm going to go ahead and connect these points, or data points, and we're going to have an approximate sinusoidal graph here. Okay, and that's it. So that is our graph. Now we're going to see what our equation is going to look like. So we're going to have to find a middle point. First, I'm going to state what our max min is. So we have a max at 2, 7.8. So I'm just going to use that point to help us for our max. Our min is 8, 1.4. So the first thing I'm going to do is look for our center, or our midline. We're going to take our max plus the min, divide it by 2, kind of find the average between the two. That's going to be 4.6. So that can be our center, our midline. Next thing to do is find the amplitude. And we're going to use our midline for that. So we can just take our maximum, subtract our midline, and that will give us our amplitude. So our amplitude is 3.2. Our period, we take a look from how long it would take us to start and finish. Looks like we have a max here and a max here. So max at time of 2. It'll be at 14. So 14 minus 2, which has a period of 12. So just look for our max times, and then find the difference between the two max times, and that would be our total period. So that's 12 hours. The next thing we're going to do is find our phase shift to determine which one we're going to use. I think the easiest one would be the cos, just because we know the maximum would hit our y-axis, but now the maximum has been moved over and looks like it'll be to the right. Okay, so we move 2 to the right, and that's if we use cos. So now we have all the information to put everything together. So y is equal to 3.2 is our amplitude. We use cos. Our frequency is 2 pi over 12, or pi over 6 in this case. So that's over here. Frequency is 2 pi over 12. 2 pi over a period. And then we put in the phase shift, so that's minus 2 because we're going to the right. And then we went up. Our center, or midline was 4.6. So that would have been your final answer.